let's talk about linear functions. We're basically putting two things together. What is a linear function? Would it help if I said line-ear function? Well, first of all, a linear function is a function whose graph is a line. So it has to be a function, so it has to meet all the rules for functions, and it has to be a line. So it has to meet both of these. So as we're going through this, we're going to review how can we tell if something's a function, okay? So from a graph, how can we tell if something is a linear function? Well, it has to be a function. And from a graph, we can tell it's a function by it passes the vertical line test. So here, this passes the vertical line test. And it is a line, so that one is a linear function. For the second one, it passes the vertical line test. So that means it's a function, but it is not a line. So this one is not a linear function. For this next one, it's a line, but it doesn't pass the vertical line test. See, right there, at that point, I'm touching several different values at one time. So this one is not a linear function, but it is a line, but it's not a linear function. Okay, here, this one passes the vertical line test, so it's a function, and it is a line, so this one is a linear function. This one is not a function because for this x value, there's two y values, and it's not a line, so this one's neither. And the last one here passes the vertical line test, and it is a line, so this one is a function, and we said this one was not. So that's one way to tell if something is a linear function. The next way is by a table. We talked before about an arithmetic sequence, which is a constant rate of change. From a table, you will see a constant change in both the x and the y. It doesn't have to be the same change in both of those, but you will see a constant change going down the x's here, plus 1, plus 1, plus 1, plus 1, and a constant change going down here, minus 3, minus 3, minus 3, minus 3. If we graph those points on a graph, on a coordinate plane, you will see that they form a line, therefore a linear function. Let's look at another one. Okay, so here with the x's, I've got plus 1, plus 1, plus 1, plus 1. So a constant change there. That's an arithmetic sequence. Here I have minus 3, minus 1, plus 1, plus 3. Not a constant change. All right, again, if you were to plot these, you can see that this makes that U shape, and it is not. That is not linear. Okay? You need to try this. Tell whether the set of ordered pairs satisfies a linear function. Is it a linear function? Pause the video and do it. Here, I've taken those and I've put them in a chart. So this would be plus 2, plus 2, plus 2, plus 2. So I have a constant change there. On the other side, I have minus 1, minus 1, minus 1, minus 1. Yes, this is a linear function. Okay, from an equation, a function is linear if it can be written as a linear equation in standard form. Now, this is what standard form looks like. AX plus BY is equal to C, where A, B, and C are real numbers, and A and B cannot both be 0. You'll notice that the X and the Y here are the ordered pair. Okay? So if you can take an equation and write it in that format, then it is linear. You'll also notice that when a linear equation is written in standard form, there's some special characteristics. The x and the y will both have exponents of 1. The x and the y are not multiplied together. The x and the y do not appear in denominators. They do not appear as an exponent, underneath a radical sign, or inside absolute values. So let's take a look here and decide whether these are linear functions or not. This one's perfect. Ax plus by is equal to c, check, linear function. All right, what about this one? No, right here, because the x and the y are multiplied together. X and y are not multiplied together in a linear function. All right, let's keep going. What about this one? Well, that's not written like that, but I think I can make it look like that. Maybe I'll subtract y from both sides. That's going to give me 3x minus y on one side is equal to negative 2. Ax plus by equals c. Check. Oh, what about this one? No, because it says that the x and the y both have exponents of 1. This one has an exponent of 3. Okay. What about this one right here? Well, if I add y to both sides, I get 5x plus y is equal to 0. Ax plus by equals c. Check. And for this one, that would be a no because x is part of a denominator. Okay. Every function has a domain and a range. And so what would the domain and range be for a non-horizontal linear function? You'll notice that these have little arrows on the end here, which means they go out forever. So if it is a non-horizontal linear function, so any line that is not horizontal, the domain will be all real numbers, because that means that the x's can go out to the right forever and then go to the left forever, and your range will also be all real numbers. So that is for any non-horizontal, and that's it.